Hello everyone. I'm a senior data scientist currently in Grainger, and I also teach at University of Illinois at Urbana, Champaign. What I want to cover today for you is 4 different cases, how we apply deep learning to solve different business problems by utilizing other knowledge, external knowledge other than math and deep learning. So, three new constructs that we've been researching on them, other than computer science, stats, math knowledge for complete deep learning solution. Business domain expertise, human knowledge level required, and the social and organizational theories, which is a collective part of this whole complete solution. So 4 cases, we are going to analyze how we utilize social theories to find machine learning and deep learning problems. 2 cases, one, generating a theory from scratch or using an existing theory. The second, how utilizing existing theories can be shifted when it comes to predictive model and machine learning model. The third case is how business domain expertise can actually create impact when your model accuracy is really good, but it's on the shelf, it's not used. So how we can actually get the most value out of it. And the fourth, what if I need a solution which does better than humans? In most of the cases, deep learning started with classifying cats and dogs, predicting some long-term or short-term time series and everything, but what if I want to create a solution which does better than humans? So we're going to take a look at those 4 cases in a short time. The first question, that was my passion, and I asked myself in 2012, I want to interact with the CEOs in social media, but they don't have any presence. They're getting scared. They hesitate to interact with their stakeholders, shareholders, investors, and other group of people. Although SEC regulated any information disclosed from Twitter and other social media is now gonna have a financial value since 2013, I guess. But still, we are lacking CEOs who are engaging in social media because they don't know how to utilize it. So the problem for the data scientists is how corporate executives should manage their accounts in online networks. How you can tie this problem to a deep learning or machine learning solution, and how you can come up with a good problem-solving approach for those people to enlighten them and to give them an idea, this is how you should utilize social media. So in this problem, what we need to do, first we are going to do our literature survey, then we are going to look at the social organizational theories currently in the literature. That's why I give high value for the spending 4 or 5 years in the PhD program. Most of the data scientists are kind of being in between. The master's enough, I'm good, I know all the skill sets, but to be able to do research is a very elegant skill that you can come up with good solutions. So, what theory I should use to design my predictive construct? First of all, identify your problems. Untapped communication medium. Previous research, we looked at it. They mostly in the news media or the face-to-face or print media that CEOs are using as a communication platform. And how I'm going to derive insights from large-scale unstructured data? Deep learning. By looking at different social theories. Once we look at the theoretical investigation, we figured out that there is this theory called impression management, which has been heavily applied in different mediums. Identified in 1982 in Best Organizational Management Journal, Academy of Management, ingratiation, supplication, self-promotion, exemplification, and intimidation. There are 5 constructs that people are heavily engaging in while they're communicating with their stakeholders. And actually the research shows that this impression management strategies enhances the career benefits of the corporate executives. So it's highly important if you can find a solution with deep learning for this problem. However, the structure of the problem is a little bit different than traditional mediums, because in social media, once you broadcast something on Twitter, you have to manage a lot of impressions for different audience segment groups. For example, you have fans, friends, stakeholders, investors, journalists, analysts. There are a lot of different segmented audiences who you need to impress at a time, simultaneously. That is the theoretical problem which have not been investigated before. So how you're gonna manage this context collect? How you're gonna manage your impressions by impressing all different kind of audiences at the same time. So this is the data flow diagram, tweet labeling, extracting features, problem breakdown, and in the end we have 84.2. To train the model, to train the text corpus, we use 16 different people who understands impression management strategies. We train them for a week, each of them. That's why you cannot use Mechanical Turks and other outsources, because labeling the tweet data accuracy is so important. So in the end, what we contributed was the impression strategies can now be detected. If you're curious how good you're doing in one of those tactics, you can use this platform to manage your social media existence. The second problem, validation of an applied theory. Okay, we implied impression management, that's good, but if we come across with a different problem, if we use a social, consumer behavior, or organizational theory, how am I going to validate the accuracy of the theory? Am I actually predicting the correct thing? One of the speakers talked about the Cambridge Analytica. What they did before the elections was using the human personality theory, identified 5 constructs of the humans who displayed in social media, mainly on Facebook. Then they assigned one of these personality classes to each person in order to target their marketing or other efforts. Then, okay, there is already a social theory has been applied, but how, I still, as a data scientist, I still need to go see, is there deeper ways that we can actually investigate? What if a person is not belong to one of those categories, for example? Is it enough, sufficient for me to create the complete solution? Or, from the business use case, how can I actually utilize this to foster my branding? How this might help, this Cambridge Analytica and other people, that human personality, social theories, how this can help my branding efforts? Can I actually foster my brand strategy by using deep learning or machine learning? First of all, I need to find a theoretical proxy for data generators, human personality, which is being used by Cambridge Analytica. But is this the right one for my brand, if it comes to my brand? Every brand has a personality that they intended to channel to their audiences and their consumers. So are we gonna be able to use the same human personality classes to solve this brand strategy efforts? No, because when we go to the marketing science literature, we identify that brand personality is a different set of personalities than the human personalities, which is only applied for the brands, different than the human personality constructs. For example, sincerity, down-to-earth, honest, excitement, competence, sophistication, like Louis Vuitton, ruggedness, like Marlboro, Harley Davidson. Those brands have different personalities. We cannot apply the human personality constructs when it comes to brand strategy problem. So then, go back to literature, look at the research on this. Human personality, brand personality, conventional matters, and social media analytics. Maybe we can apply and create a novel solution for this. We use a lot of different sources to train the model. In the end, we use LDA, work-to-vec model, to actually supervise our algorithm. We use unsupervised technique to label the data. So we didn't let any human intervention to label the data. This was the first approach, how we can use machine learning actually label the data and make it ready for training. Word embeddings, comparison of classification algorithms. I can give you detail later on, but and then we validate the model with the human coders in the end and other metrics. But I'll discuss a little bit of our results. We had some brands that we tested our model. For example, sincerity, domestic, honest, authentic, genuine, cheerful. That are the most common traits for sincerity. And Virgin America is actually leading on that. And McDonald's is the second, which is actually consistent with what their CEO Easterbrook said. Our food, your question, they decided to be more down to earth after 2015, and you can actually observe this, examine and monitor this personality change by this tool. Ruggedness is a trait composed of challenge and devere, outdoorsy. Nike and Cabela's outdoor Jeep is the leading ones in this. The Discovery Channel and Jeep is actually on the news media as being taught the best ruggedness personality characteristics. Sophistication, charming, luxury, glamorous. Burberry, Louis Vuitton, Victoria's Secret, top 3 as we expected. Competence, hardworking, leader, intelligent, reliable, responsible, proud. Deloitte, BCG, McKinsey is the highest scored one on this. FedEx is the fourth one. We looked deeper on that. FedEx says safety will be the first consideration in all operations. Corporate activities will be conducted to the highest ethical professional standards. Actually, reliable and the responsible part, they invested heavily on, they changed their personality, and we can actually quantify and measure it right now. Excitement, cool, young, aggressive. Red Bull, obviously not surprising. What if within additional demonstration, if within the same industry, let's look at the insurance companies. 3 insurance companies we picked: State Farm, Allstate, Geico. State Farm is like a good neighbor. State Farm is there. They're channeling mostly down-to-earth, friendly, genuine personality. Allstate, you're in good hands with Allstate, caring, genuine, tender, again, sincerity mostly, without using our tool. Geico, they're a bit aggressive, save 15% or more in car insurance. They're always yelling at the advertising. So there is actually personality behind what they're trying to channel. And when we run our tool, we actually saw very consistent results. State Farm, Allstate, sincerity, and Geico, excitement, aggressive, audacious, bold, brave are the traits of excitement class. But this is the channel personality from the brands. How about human side, consumers? We have still ongoing research on. What we propose is, what users in social media is actually not displaying the human personality, but the brand personality, because we think that the people are being ideal themselves, not the real one in social media. That's why they behave more likely as brands than humans. Because the definition of brand personality is aspirational, or the ideal personality that the people are getting emotional attachments. So the people and the users in social media, humans, are actually engaging in brand personality tactics to display themselves. So it's still ongoing, but this tool can be improved to detect those as well. One interesting application can be on this after we publish this paper. Celebrity marketers may use this tool to identify the most appropriate endorsers for their brands. You can look at the celebrities' personality dimensions, and you can look at your brand's personality dimensions. If there is a similarity, then you can pick the right one for your consumers. Okay, the third case. Business domain expertise for deep learning solution. We unlock the insights. Okay, but how we are going to create an impact and build a strategy on it? One case we came across. The problem is predicting credit card purchasing behavior by using recurrent neural networks and LSTM architecture. Okay, we did a pretty good job. Our prediction accuracy is really good. But then what? How am I gonna create a business impact with this solution? This solution waited on the shelf for 6 months because the business leaders didn't know how they can use it to create value out of it. That's why data scientists has to have a developed business acumen or the domain expertise in order to leverage best from our solution. When we look at the McKinsey report, actually they are trying to create the systems to detect late night credit card usage, to detect stressful consumers, and they're increasing their credit card line and they're boosting their sales. So how then this solution is actually really helping to them to increase the credit line on time and boosting their sales. I think I'm like off. Good? Okay. Okay, the last case. This is my favorite. Human knowledge level for deep learning. What is human knowledge level? How can I detect the things that the humans cannot identify? For example, how can I detect if a person lies? As a human, I cannot know. But how can I use deep learning to detect this? Health and life insurance forms. There are 2 sections. Tobacco usage behavior, non-tobacco usage. If you're a non-tobacco user, then you pay less premiums. If you're a tobacco user, you pay high premiums. And the people, the insurance companies were complaining, they came to us and complaining, we know they're smoking, but they're not checking their box to pay less premiums. How we can use deep learning to detect their lying? Solution is selfies. We said we can create a model to predict if a person is smoking or not, or formerly smoker, or an existing smoker, by utilizing deep learning face recognition methods. Before developing that model, we look how we can predict the age from the selfies, how we can predict the gender from the selfies, how we can predict the body mass index from the selfies. There are a lot of open online resources. For example, one of them was the Reddit progress pictures before and after. The people are working out, they're posting their weights and everything. We utilize for that to train our set and predict the BMIs. Now, the tobacco usage model is being deployed. You're uploading your selfie picture to the insurance company, and they're providing you the real-time quote just from your selfie picture, or profile picture. Our feature research stream is focusing on more biomedical measures in the healthcare domain, anxiety, depression prediction, and risk of suicidal. This is actually can be a use case for insurance companies, but we want to do it in our university to predict the students who are under depressed and stressed, that we can actually help them and provide support for them to enhance the overall success. So then we're gonna start taking pictures of every student every 3 months, and we're gonna look at the patterns and if we're gonna be able to predict any anxiety pattern on those selfie pictures. Well, that's it. Sorry for I can get questions.
Hey,
Yes.
I don't know, should I get a microphone or this is a good turning point? But first of all, thanks for coming here. I mean, I like your presentation. So I'm not a data scientist and a quantity geneticist by knowledge by applied statistics. Main issue that we have in genetics, we were trying to map genes, are the rare genes. How I translate this, what is the context of this question is this. Rare personalities, how able deep learning is going to be able to capture that? What is going to be approach to address that? And let me tell you a little more about the context. Like a rare personality, somebody get mad and start shooting people. Myself, I try just to develop something for that. The main issue is that like outlier. That like in a normal distribution, knowing machine learning doesn't assume linearity, but in a normal distribution, that's like kind of outlier. And outliers are super hard to predict. So in the context of this, how are you going to manage just rare personalities for your like prediction tool for like Twitter? How do you want, just simple question, how are you going to handle like rare personalities or outliers in your data? How are they going to affect your deep learning prediction?
Yeah, that's a very good question actually. In order to propose something, you have a lot of statistical tests. Like you have to consider those outliers and the extreme values into your model to be able to make your model generalizable.
But those outliers are true information. Somebody getting mad and start shooting people, that's true.
Yeah, then I want to detect that.
But how? I mean, it's a rare observation. It's rare. I mean, I try to do this for my own, for like a mass shooting. I'm not a psychologist, I'm a genetic quantitative, but I try to map like what is, I like start doing shootings. So what are the major traits? Introverts, I could be able to classify them by introverts. I was able to classify them by not having that many friends.
Yeah.
But what do you do, for example, with the guy in Vegas who play a lot of cards? He just went mad and started shooting like all the people in Vegas. That actually screwed up my data.
That's
Yeah, I mean that's true. That was hard to try to do it.
yeah. There is this. Where is that? Yeah, neuroticism. Right. So what we are actually observing, trying to do right now, how actually this human personality characteristics is aligning with the brand personality. Because if a person is a brand of itself, then it displays brand personality. But in the end, it's a human. So how we can actually merge these two, maybe including your extreme cases as well. So we have to match the neuroticism with the excitement or something. I don't know. We are working on that. But good question.
How is the insurance company legally allowed or able to get those photos of incriminating behavior like smoking?
So they applied $5 discount if they let life insurance applicants take their pictures to the people who display their smoking or not. So they collected the pictures of the applicant with their consent by offering some discount. Then they trained their model to be able to predict the upcoming ones.
So not a picture of them smoking, but could there be like other smokers?
Yes, there is no cigarette in the picture. That's the beauty of deep learning. With facial landmarks, other things, there are a lot of features on a face that the model is actually identified and match with the smoker faces to be able to give a probability how likely this person is actually smoking. Okay, any other questions we have? Yes.
You mentioned you label your data with hash. How did you achieve that with unsupervised learning?
So yeah, that's a good question. We looked at the dictionaries had already published. For example, in here, Aker and Opaku, there are two different researchers who already provided some dictionaries who's actually assigning one of those characteristics, and we use the word embeddings of those words and the dictionaries, and map it in the clusters in the LDA. Then we label them with the appropriate class in the dictionaries. So we wrote the raw data, LDA topic classification, word-to-vec integration, and we included the personality dictionary, which have 5 classes, and we mapped those vectorial representations in one of those classes without touching it.
Yes. A following question for that part. So, you mentioned you use the topic model. So, how accurate that model give you answer for this case? Because usually I'm running that model, I do not get a really good result. So
yeah, it's not giving you any accuracy. It's an unsupervised. We just wanted to see how the clusters are gonna behave when we use the word embeddings, and how the clusters are gonna change when we apply a previously published dictionary on it. So I want to make it clusters granular and more readable or better refined by using those dictionary word embeddings. So it's not an accuracy performance, but it's just beating the posts and the social media footprints in one of those refined clusters by using word embeddings of that dictionary. I think we're, yeah, okay. Thank you.
Thank you so much. Thank you.